Have you ever looked at a massive bridge, or a skyscraper, or even just the perfectly straight lines of a highway and wondered, how? How did they get it so perfect? Well, today, we're pulling back the curtain on the hidden science that literally shapes the world around us, surveying. It's the reason our biggest, most ambitious ideas actually work.
And to really get a feel for just how powerful this science is, let's start with a puzzle. A massive, almost unbelievable engineering puzzle. Imagine you have to connect two different countries, and they're separated by an entire sea.
No, seriously, think about that for a second. You have one team starting in the UK, another starting in France. They're digging towards each other, under the English Channel, completely blind. How in the world do they make sure they actually, meet? The level of precision needed is just staggering.
And this is what happens when you solve that puzzle. The Channel Tunnel. This 50-kilometer marvel of engineering wasn't a lucky guess. It wasn't magic. It was the result of a science designed for exactly this, figuring out the precise position of anything anywhere on Earth. And that science, the hero of this whole story, is surveying. It's the quiet, unsung discipline that lays the groundwork, literally, for almost every single thing we build. So what is it, really? Well, the official definition sounds a little dry, but the idea behind it is actually pretty simple. When it says relative position, it just means figuring out exactly where one thing is in relation to everything else around it. How far away is it? How much higher or lower? What's the angle between them? That's the core of it. Let's break it down even more. Think about building a house. It's a simple three-step process. First, a surveyor comes out and measures everything: the hills, the valleys, the shape of the land. Step 1, measure. Second, they take all that data and turn it into a super accurate map for the architects to use. Step 2, map. And third, they come back to the site and put stakes in the ground to show the builders exactly where the foundations need to go. Step 3, guide. Measure, map, guide. That's the secret sauce for every project. But of course, it's not quite that simple, because measuring our planet comes with one colossal challenge, a fundamental problem that every single surveyor has to wrestle with. And here it is. The biggest problem in surveying is that the Earth isn't a perfect sphere, not even close. That perfect blue marble we see in photos, it's a bit of a lie. And that little imperfection changes everything. In reality, the Earth is what's called an oblate spheroid. That's just a fancy term for being a little bit squashed. It bulges out around the equator, and it's kind of flattened at the poles. So think less of a perfect basketball and more like a slightly sat-on orange. This more accurate lumpy shape is what surveyors have to work with. And how much of a difference are we talking about here? Well, the diameter of the Earth at the equator is nearly 43 kilometers wider than it is from pole to pole. That's a massive difference. You absolutely cannot ignore that when you're trying to make two tunnels meet under the sea. So this one single fact, that our world is this bumpy, imperfect spheroid, forces surveyors to choose between two totally different ways of doing their job. On one side, you've got plain surveying. For smaller projects, say under 250 square kilometers, you can basically just pretend the Earth is flat. It makes all the math way easier. But for the big stuff, like the Channel Tunnel, you have to use geodetic surveying, which takes the true curved shape of the Earth into account. And this image right here shows the key difference perfectly. When you're doing plane surveying, you just assume that gravity pulls straight down everywhere, so all your plumb lines are parallel. But in geodetic surveying, you have to remember that gravity is actually pulling everything toward the center of the Earth, so those lines all converge. Okay, here's a wild fact that proves just how different it is. You know how in school you learned that the angles in a triangle always add up to 180 degrees? Well, not on a curved surface. In geodetic surveying, if you make a huge triangle, like connecting 3 different cities, the angles will always add up to more than 180. The basic rules of geometry get warped by the shape of our planet.
So that begs a pretty obvious question, right? If the Earth is definitely curved, how can we just get away with pretending it's flat sometimes? Well, it all comes down to something called acceptable error.
Let's just pick a distance. How about 12 kilometers? That's about 7.5 miles. A pretty decent stretch. Now, imagine you drew a perfectly straight line like a cord going through the Earth for those 12 kilometers. Then you measured the actual curved line along the surface. You'd think the difference in length would be pretty significant, wouldn't you? Well, it's actually 1 centimeter. That's it, just 1. Over a massive 12-kilometer distance, the error from pretending the Earth is flat is tiny. For building a house or a local road, an error that small is completely, totally fine. And that right there is the surveyor's secret weapon, knowing exactly when you can get away with simplifying reality.
Okay, so now that we kind of get the how, let's look at the what. Because surveying isn't just one single thing. It's a whole family of different techniques that are being used all around you every single day.
You can break them down into 3 main buckets, and it's pretty straightforward. Land surveying happens on the ground. Hydrographic surveying is all about mapping bodies of water, lakes, rivers, the ocean floor. And aerial surveying, well, that uses technology up in the sky.
Here's a type of land survey that most of us have a connection to, even if we don't know the name: cadastral surveying. That big word cadastral just means it's about legal property lines. You know that map you get when you buy a house? The one that shows exactly where your yard starts and your neighbor's begins? Yeah, that's the work of a cadastral surveyor.
And today, the technology we have is just incredible. Aerial surveying, also called photogrammetry, uses special cameras on planes and drones. By taking tons of overlapping pictures, they can create these amazingly detailed 3D maps of huge areas, even places that would be impossible to walk through.
But at the end of the day, it all comes back to this. Whether we're planning a new highway system, laying down a railway, designing a city's water pipes, or mapping the deepest parts of the ocean floor, it all starts with surveying. It is the essential first step, the foundational data for our entire built world. So really, surveying is so much more than just measuring. It's like a hidden language. It's the language that lets us translate an idea in our heads into a physical reality on the messy, complicated canvas of our planet. It built everything we see around us, and it makes you wonder, what incredible things are we going to build with it next?